actually did congruent triangles in year 9. I know, a while ago, and probably in year 10 we ran out of time to look at them. So who remembers there's actually 4 things that we can prove for congruent triangles? 4. Angle. So I call that AS. Angle, angle, side angle. Now I'm going to start. So, yep, SSS. So that is, and don't write this down at the moment, we're just brainstorming because I'll show it's very nicely done in the book. SSS, so side, side, side. So if you've got if I've got triangles and I can say that each pair is the same, right, then we'd say they are congruent. So side, side, side. Then we have what I call a sass. A sass me. Don't sass me, boy. Right? That is if I've got 2 lengths, angle in the middle. Where have we seen that before? And, oops, trig. So what if I have... Now, would these be sass? No, because that angle is not in between the 2 sides. So it's side, angle, side. So that has to be here. And then we can go, haha, they're congruent, exactly the same. Yes? As, angle, was it angle, angle, side? Angle, angle, side. Not a huge fan of how the book does it, but we can have this one, and I could have this angle here. And then I could have this one. Where would the angle have to go for it to be the same? Oh, angle, angle, side, sorry. I was getting excited, sorry. Oh, now I have to undo that one. Whoop. Whoop. Let's go here. Let's go here. Where would my other angle have to be? Right into the microphone. See how it's opposite there? Then it has to be opposite here. If it was there, no-y goey. All right? And I swear this is drawn really nicely for you. I'll show you in the book because this is bad. And then what's the 4th one? RHS, right hypotenuse, side. So if I have this one, I've got the right angle, I've got one side the same, and it has to be the hypotenuse. So can I make a right angle here? It has to be the hypotenuse and then that other side there. Be careful because you actually always have to give the reason as to why something is congruent or not. We're going to do a quick run through of that in a minute. So where can you find this? Have to move it along. So in these questions, we want to show or say, are they congruent or are they not? So there could be some that are not. So with the first one, are they congruent? Why? I've got 2 sides and an angle. So yes, and they are because of sass. Sass. What about B? Opposite there, not right angle because it's not indicated. So I would say this is because, oh no, is it? No, I've got 2 sides and an angle, but that's not one of our properties. It's not enough information to say they're congruent. Agreed? It's what? Yeah, this has to be in here. If that was in here, then we could go sass, but it's not, so no-y goey. All right, what about C? Excellent. I'm saying yes because of side, side, side. You've got this pair, this pair, this pair, this pair, and this one is what we would say is common or shared. So they've got 3 pairs of equal lengths. Okay, what about D? Absolutely, yes. We've got a side. We've got a side. Now, this is the thing, yes. We want to say RHS because we see the right angle, but remember, RHS, it had to have, the H stood for the hypotenuse. We do not know that the hypotenuse is the same. However, we've got a common side here. That's 90 degrees, that's 90 degrees, so we've got an angle in between. So this is correct because of SAS. And this is the bit, if you had put it's congruent because of RHS, you would have actually lost a mark. So yes, it's congruent, but you've got to pick the right reason. Does that make sense? What about E? What have we got? We've got so this is one of the ways that you could go. Yeah, good, Joe. It's not indicated, so you can't. One of the ways you could go if you're unsure, I write them down. SSS, SAS, RHS, and AS. Now, there's no right angle, so that's out of the game. Do we have all three lengths? You're out. Have I got side angle side? No, and I haven't got, so I haven't satisfied, so I haven't got that information. So that's a quick, you don't have to stare at it for hours. List it down and decide immediately. Agreed? Are we good? We reckon we've got this? How about we jump to H? Yeah, good. People have noticed these. What does that allow us to say? Parallel, which means alternate angles. If that is the same, that angle is the same. And anything else? Can I go the other way? No. Right, so I've got a side. I've got an angle. Now I've got a common. I feel like I want to. So technically, I think, so it says you're not allowed to prove any properties of isosceles triangles, but you could say that it's a parallelogram because they're the same length. But I think you'd have to prove it's a parallelogram first and then. Correct. So for H, without looking at the solutions, I'd be saying H is yes, but we need a couple more steps. They said we weren't allowed to use isosceles, but didn't say we couldn't use the properties of parallelograms. So I'd say we probably could. Anyway, onward. So no need to write the whole question, just draw your diagram. Now AC is 6. So A to C, pop your 6 there. Angle BAC is 42. BAC. So again, not only is it helping you to read, but it's showing you how you can write down information. Oops. And we had to do part A first. Bad me. Bad me. That's all right. We can pop that in. Okay, explain why triangles ABC, and you can see ABC and EDC, why they're congruent. Absolutely. Can everyone see why it's side angle side? Because these are the same, they're vertically opposite. So to write this up, we would say angle BCA equals angle ECD, vertically opposite. We've got now the length, what did we say? The length of, no, we can't say side angle side because we haven't got another side length. We've got length BC equals CD. We've got given. So we've got a side, we've got an angle, and have we got another angle? And why? Because we've got parallel lines. So, because they gave us, like, in the next bit, this is 42. Yeah? This one here would have to be 42. And it's opposite that same length. So we're good to go there. So we can say, and angle BAC equals angle CED, yep. And why? We're not allowed to just say parallel. Alternate. Very good. Now, those are on those sheets. Has everybody got their sheets with them? I've got a spare one. EC is congruent to triangle EDC as. Because they are congruent, this length is the same as this length, and this length is the same as this length. So when they're saying what's the length of CE? Has to be 6. What's the size of angle DEC? Has to be 42. So once you've proved that triangles are congruent, then you can say that other things are the same. Agreed? Hello? Congruent. So the question was, what are these 3 lines? Congruent. Chance to read it, but let's not bother too much with the write-up. Let's do the main. Why and how are they congruent? So draw some things. What is one of the key bits of information, do you think, in this diagram? Pardon? O is the center of the circle. So, what do we know about radius? And maybe there's another radius. We won't do it because we got the screwed up face over there. So, given the diagram, establish the angle of establish the angles of a triangle theorem. So, what is the angles of a triangle theorem? All the angles have to add up to be 180, but we have to prove that. Now, again, what do you notice? What do you see in that diagram? What do you notice? What do you think? Yep.
I was just going to say because the lines are parallel.
Absolutely. You suss that the lines are parallel, and so this angle here has to be what? B, because they are alternate. And this angle has to be because they are alternate. And what do we know about the angles in a straight line? Adds up to 180 degrees. So A plus B plus C adds up to 180. Bang, you've proved that A plus B plus C add up to 180. It is beautiful, isn't it? So this is some of the stuff. Now, I think we will do number 2, just because this is the theorem that you will use in your circle properties, and it's overlooked so often. And it's probably one of my favorite theorems. If it's possible to have a favorite theorem, this is one. So, Rian again is in control at the back because he's right near that poster. What is the exterior angles of a triangle theorem? So I'm going to draw a little bit differently. No, I won't. I'll draw it the same. So if we're like this, and we have this angle and this one, then we know that that angle, see how it's extended? That is A plus B. So we want to prove that using our diagrams. And once again, what's the standout feature? Parallel lines. So look at your little formulas, see if you can rotate stuff around, and who would like to come and draw on the board. So sorry, we just joined all the bits and pieces together, and then we notice that we've got radius here. These are the things to prove congruency. We have got a right angle, so our eyes go to this, but we have to make sure that the hypotenuse is the same on each. And as Felix said, the hypotenuse, OP, is common. So now let's write this down. So we say OP is common. We've got OA equals, I get tired of writing the lengths. You probably don't need to write the modulus lengths there if you don't want to. I probably will stop doing it soon. Is equal to OB, Y, radius, okay? And last but not least, we had angle OAP equals 90 degrees. Why? Yep, I go radius, tangent, tangent, radius. I don't know why I did radius first then. It's normally radius, tangent. And we can say, and similarly, OBP equals 90 degrees, radius, tangent, and that is equal to OAP. Therefore, Therefore, triangles are congruent. Y, R, H, S. Don't do all of that hard work and forget to give me the reason why they're congruent. Keke?